It's basically 9 o'clock, so we will start. The first topic we're going to look at is trigonometry. Now, there's some learning that you need to do here, all right? And I can't help you learn this, but you need to learn the definitions of this. There's 6 trig ratios, okay? There's sine, and the upside down of sine, if we turn it over, we actually call it the reciprocal, sine and cosec, cos and sec, and tan and cot. Okay, we need to know them in the Cartesian plane. All right, in mathematics, okay, so everything's connected to everything else. Later in analytical geometry, we're going to be working in the Cartesian plane. But the Cartesian plane, you know that any point has got an x value and a y value, and then it's also got an r value, and that's the distance from the origin. Okay, so you need to know these in this format. You also need to know them in a right-angled triangle. Now, when we've got a right-angled triangle, the side opposite the right angle is called the hypotenuse. The side opposite the angle is called the opposite. Okay, and this word here is adjacent, and it's hey, sorry to keep you up. All right, adjacent actually means next to. Okay, now you might say, Paul, this one's also next to, but this one's got a name already. Okay, if we were to swap this angle, and if we were talking about this angle being theta, what would this side be called now? Would this be the opposite or the adjacent? This would be the opposite, and this one would be the adjacent. Okay, but for the way we had it, opposite and adjacent. So you need to also learn all these ratios, that sine is opposite over hypotenuse. Cosec is the upside down of sine. It's hypotenuse over opposite. Cos is adjacent over hypotenuse. Sec is hypotenuse over adjacent. Tan is opposite over adjacent. Okay, now we expect you to be able to know the trig ratios of some of our angles, all right, without a calculator. Okay, so you might say, how will they know if I've used my calculator? Sometimes later in grade 12 for university entrance, you have to write a thing called the National Benchmark Test, and there's no calculator allowed. Okay, so it's worth learning, and you've got a choice. You can either learn these 2 triangles, okay, we call these special triangles, or you can learn this fan. Okay, I actually like the fan, and I'm going to explain to you how to draw the fan. You basically draw a 30-degree angle, 45, 60. Those are our 3 special angles. And then we have a radius of 2. Okay, so this point I write as the square root of 4. What's the square root of 4? 2, yeah. And the square root of 0, which is just 0. The next point, you can see that as we move around here, the x value is a little bit smaller and the y value is a little bit bigger. So this now becomes the square root of 3, the square root of 1. The next one, we make the x value smaller by 1 and the y value bigger by 1. Square root of 2, square root of 2. And the last one, square root of 1, square root of 3. Well, the very last one is at 90. And then square root of, because this is ai corriente. This is rubbish. Okay, what's wrong here? This should be the other way around, eh? Just please cross that out. This should be the square root of 0, square root of 4. Okay, right, now I'm going to just show you a couple of these. If I asked you for the sine of 45, we're working in a triangle. Who can tell me what is the sine of, what's the ratio, what's the rule for sine? What's the definition for sine if we're in the triangles and we're talking about opposite, hypotenuse, and adjacent? What is sine? Sine is opposite over hypotenuse. So the sine of 45 is going to be, where's the opposite? What's the opposite? 1 And the hypotenuse? Square root 2. Okay. All right. I'm going to go across to the fan here, and I'm going to ask us for the cot of 60 degrees. Now, because we're on this side, I now need to know what is cot with x, y, and r. Who can tell me? Ayanda's walking around. She'll have there's some smaller sweets in the bag here, and she'll have some sweets. And if you answer correctly, or even if you try, then we can give you a sweetie. Okay. So who can tell me what is cot? Is cot r over y? Is it r over x? What is cot? We need to learn this, guys. By the end of today, we need to know these cot. What do we divide by what? And I'm wanting, over here we're using x, y, and r. Over here we're using opposite, hypotenuse, and adjacent. Who can tell me what is cot? Just put your hand up. Someone put your hand up. And Ayanda will come to you. What is cot? It's written on your page, so it's not difficult. What is cot? Okay, so I'm working here. So I actually want it in x, y, and r. You are right. It is adjacent over hypotenuse. It is adjacent over opposite. It's also x over y. Keep the microphone and tell me what will cot of 60 degrees be. Now 60 is this biggest angle where I've got my green line. What will cot of 60 be? What's the x value and what's the y value? It will be 1 over the square root of 3. Okay, x over y. All right, I'm going to do 2 more together. And now I'm working in the triangles here. I want someone to tell me what will tan of 45 degrees be. But I want you to tell me firstly, what is tan, and then what's the answer? Okay, so just put your hand up if you know. And I need you to tell me what tan is using these words. Okay, so someone just put your hand up quickly, and because I don't want to spend too long doing this. Yeah. Thank you. Halala. So tan is opposite over adjacent. Here's 45. What will the opposite be and what will the adjacent be? Yes. So we get 1 over 1, Norma, 1. Okay, halala. Okay. I want someone to tell me now what will be the sec of 60 degrees. Okay. And I want you firstly to tell me what's the ratio for sec in terms of x, y, and r. Now, guys, you don't get given these rules. If you don't learn these, you cannot do trigonometry. Even when you write matric, you never get given these 6 definitions. Okay, what is sec?
Hypotenuse over adjacent.
R over x, halala. And so what will it be for 60 degrees? Here's 60 degrees. R over x, what will it be? Two over 1, well done. It will be 2 over the square root of 1. The square root of 1 is just 1. It will be 2 over 1. It will be 2. Okay, right. Now, guys, I want you to, we're going to do a couple of examples. We're going to come back to this, all right? I want you to just try question 1 together. You can work on it together on just question 1 on page 4.
4.
Page 4, question 1. Don't use a calculator, okay? Just maybe we can do this together. Guys, watch this. Let's draw the fan. Okay. So on your page here, just on the side, you can draw it nice and small, 30 degrees. Now, remember that 90 degrees is root 4, root 0. Does anyone remember, what do I do when I go to 30 degrees? What do I do? Root 3, root 1. Hala. Then when I go to 45 degrees, okay, so this is 45 degrees. What do I do? Square root 2. This one's getting smaller. This one's getting bigger. Okay, and then lastly, when I go to 60 degrees, square root 1.
Yes.
Square root 3. Okay, so this green angle is 60 degrees. Remember the whole way from there. Okay, this one's going to be square root 1, square root 3. Now, I'm happy that you just use the fan. Normally, you just use the triangles. I'm going to quickly draw the triangles. The triangles look like this. One of them is what we call an isosceles triangle. It's got a 90, a 45, a 45, a 1 and a 1, and a square root of 2. The other one is not an isosceles triangle. It's got a 30 degree, it's got a 90, it's got a 60, and we're going to talk about this just now, but in a triangle, the biggest side is always opposite the biggest angle. So 2 over there, the smallest side is opposite the smallest angle, 1 over here, and if you can't remember the other one, you could use Pythagoras, but it's the square root of 3. The square root of 3 is about 1.7 or something. I can't remember. Okay, I want you just to try these questions. I'm going to take some answers soon. I'm just going to look for a calculator in the meanwhile. Okay, you don't have to do them both ways. You can choose. Okay, you can choose the fan. Normally, you can choose these 2 triangles. Yeah, you're welcome to talk to the person next to you, as long as you're talking about maths, all right? Because it's more fun to do it together. All right, let's get a couple of answers. You can keep working, but let's see if someone can tell me what is the sine of 45 degrees. And I just want your answer, and I'm going to tell you if you're right or wrong. If you're right, you're going to get his read. Sine of 45. I don't want you to use a calculator. Put your hand up. There we go. We've got a hand there. Hand up. There's a. Okay.
One over square root of 2.
Okay, I want to just check something on my calculator. You are right. Well done. But just check here, guys. If I go sine of 45 on my calculator gives me something else. It tells me the square root of 2 over 2. These are both right. Okay, did you use the triangle? I know you used the triangle because the triangle gives it to you as 1 over root 2. The fan, guys, sine is y over r. Remember, r is 2, the whole way around here. So the fan would give you root 2 over 2. Can anyone tell me, how do I show that 1 over root 2 is the same as root 2 over 2? What do I do? I multiply by, well done, I multiply by 1, the square root of 2 over the square root of 2. This here is 1. Now, when I multiply on the top, I just get a root 2. On the bottom, I get root 2 times root 2, which is 2. Okay, for this, we can use either answer. Okay, but the reason I am this thing I call the fan, okay, I am a fan of the fan because it gives you the answer straight with the rational denominator. All right, next up, tan of 30 degrees. Just put your hand up if you know what the tan of 30 degrees is. Try and, guys, I've told you this before, but don't just sit here and don't try today. I need you to try. Singakhetha, singahamba njengekalikuni. Noma singandiza njengokhozi. Okay, we can choose. We can walk like turkeys or we can soar like eagles. Today, I want you to soar like eagles. Right. Tell me, what's tan of 30? Hala, 1 over root 3. Okay.
1 over
it's
3.
Also root 3 over 3, but that's fine. Let's go next door. Cos of 60 degrees. Cos of 60. There we've got an answer. Well done. Hala. Next. Cosec of 60. Cosec of 60. I'm going to ask Ayanda to come closer to the front just now because at the moment she's in the back row. I need her to get her steps up for vitality, for discovery.
It says error.
2 over square root 3. Hala, well done. It's guys, cosec is the upside down of sine. Okay, cosec is r over y. Sec of 45, someone. Sec of 45.
Two over 2.
Hala. Someone on the online told me 2 over root 2. Okay, guys, sec is r over x. Okay, cot of 45. Come, someone here, so Ayanda doesn't have to walk so far. Wait, cot of 45.
1 over 3.
No, someone said 1 over root 3. No, cot. Sorry. Yeah, no, cot of 45 is not 1 over root 3. Sorry. Next, yeah, at the back
Yes.
here.
1 over 1.
Okay, cot of 45, if you're using the triangles, cot is going to be your adjacent over your opposite. Norma is going to be your x over your y. You get 1. All right, sine of 60. Sine of 60. No. Cos of 60 is 1 over 2. Sine of 60. Hello, it's root 3 over 2. It's either, guys, it's either y over r or it's opposite over hypotenuse. All right, cos of 30. Cos of 30.
Root 3 over 2.
Done. Well done. Root 3 over 2. And the last one, tan of 60. Well done. Root 3 over 1 is just root 3. Hala.
Yes.
Okay. Are you giving these guys a sweet? Hala. Okay. Right. Now, guys, I want us to go back in our book here. And I'm going to show you some trigonometry in the Cartesian plane now. Okay. I'm just looking for my sketch here. There it is. Okay. So, right. So guys, when we measure an angle, and I want you to watch this carefully, when we measure an angle in mathematics, we start at what I'm going to call east. Norma, I'm going to call it 3 o'clock. If you picture a clock, okay, 3 o'clock is here. And we go anti-clockwise. Look at this angle. It's going round like that. Okay. All right. Do any of you do geography? Okay, if you do geography, we start at 12 o'clock or north and we go the other way. We go clockwise, yeah. But in maths, we go anti-clockwise. Now, I want to show you for any place here, wherever this point is, we can work out these ratios, sine, cos, and tan. There they are. So, for example, if you might remember that just now we looked at the tan of 45 degrees, all right? And at 45 degrees, what you'll notice is that your y value and your x value are the same size. So tan of 45 is your y over your x. Tan of 45 is y. Okay, does it make sense? It always makes sense. I want to show you something here. This circle at the moment has got a radius of 8. Cordwa, if I make the circle bigger, what you will see is that the tan of 45 is 1. It doesn't matter how big the circle is, because however big the circle is, let's say the circle's even 14, okay? If my hand's steady enough, okay, whatever, there's 14,07. Look at the x value and the y value, they are the same. So tan of 45 is always 1. The circle size does not matter. I'm going to leave the circle at 8, okay? Now, what I want to show you, in this first box, and I'm going to call it a box, I'm also going to call it a quadrant. Quadrant number 1, from 0 to 90 degrees. Which of the ratios is positive? Sine, normal cos, or normal tan? All of them. Okay. If I go into the second quadrant, my R value is a length. R is always positive. In the second quadrant, in this box over here, is X positive or negative? Negative.
Negative.
Okay. And Y is positive. So when I, for example, if I'm finding cos is X over R. In this quadrant, cos will be negative. Tan is Y over X. Tan will be negative. Okay. But quadrant, sine will be positive because sine is going to be Y over R. If I go into this box over here, quadrant number 3, which trig ratio will be positive? Who can tell me which trig ratio will be positive in quadrant 3? Okay, let's find someone a bit closer to the front here. Surely, all these Injalova learners, which quadrant, which ratio will be positive here in quadrant 3?
10.
10.
Sorry? No, which, I'm asking you, will sine be positive? Norma cos be positive? Norma tan be positive?
10 will be positive.
Huh?
Tan
No.
will be positive.
Tan, yes, hala. Tan will be positive. Okay, tan will be positive. And guys, I want you to have a look. Because when I get into quadrant 3, the x value is negative and the y value is negative. Remember, R is the length. It's never negative. So sine is negative because it's a negative divided by a positive. Cos is negative because it's a negative divided by a positive. Quadrat tan is positive because it's a negative divided by a negative. Remember in grade 8 we learned about integers. You divide a negative by a negative, you get a positive. Who can tell me which trig ratio, and this any Lord one, out of sine, cos, and tan, which one will be positive in quadrant 4 over here between 270 and 360 degrees? Which one?
Cos.
Yeah, I'm hearing the answer online from the online learners. Well done. Yeah, here as well. Anyone in the room? Yeah. Cos. Let's have a look, guys. If I go around here, cos is the only one that is positive. Cos is X over R. Sine is Y over R. Tan is Y over X. But the reason that cos is positive is because that X is positive. Okay, now I want you to go to this page on your workbook, page 3. All right? And I want you to write what's the upside down of sine? If you turn sine upside down, which ratio do you get? I'm Kelly Keeler. Okay. Sorry, which one do we get? Cos Guys, cosec is positive in quadrant 2. All right? What happens when you turn tan upside down? Which ratio do you get? Cot. Okay? And what happens when you turn cos upside down? Sec. Okay.
Sec.
Now, so all of them, all you can even write here, all 6, okay, are positive in quadrant 1. What I also want you to write on this diagram, okay, and I've left things off this diagram on purpose so that you keep focus. This is 0 degrees. This is 90 degrees. This is 180 degrees.
180.
And this is 270 degrees. This is also 360.
360.
Okay, so when I say 100 degrees, which quadrant am I in? 100 degrees. I'm in quadrant 2.
102.
Okay. And if I say to you 300 degrees, which quadrant am I in?
Quadrant.
Quadrant
1.
Guys, I'm in quadrant 4.
4.
Okay, and if I say to you 200 degrees, which quadrant am I in? 3.
Quadrant
Okay.
3.
Okay, right. So now what I want you to do, I want you to go back to this question and I want you to over.
Yo, nayo.
People, guys.
Kesa kan?
And mine.
Sekwenze njani manje?
Yathuka.
Usifake kumute.
Sakuyouth. Uyabona kodwa?
Akaboni.
Hayi bo, nje sifaka
Hayi
kwi-mute.
mina. Hayi phela kayi unmute.
Hayi bo, ngempela size phela thina.
Oh,
Sibuze nje thina.
Abakasekuthule la. Ngiyahleka.
Ukanti ngiyahleka yazi bayaqhubeka bayafunda abanye.
Sinasonta yini?
Okay. Guys, there's a lot of noise coming through. So unfortunately, what I'm going to have to do is I'm going to mute everyone. Okay. You can answer the questions in the room, but otherwise it's just very distracting here. Keep answering the questions. Okay, and I'm hoping that, yeah, I think you guys can hear me still. All right, so if we can go. Okay, I'm just going to try that again. More settings. Okay, I think we've won with it now. All right. So let's get some answers. Is sine 200 is positive? True or false? Let's get don't shout it out. Let's just get hands up.
false.
False.
So I'm still having managed to mute everyone. Oh, dear. Yeah, guys, I'm just going to mute people because it's very hard for me to concentrate with lots of answers. Okay. Right, let's go. So let's go quickly now because this is quite easy, I think. True or false? False. Well done. Okay, halala. Okay, tan of 230. Tan of 230 is positive, true or false? Someone else? True, well done. All right, guys, tan of 230, we over here. Tan is positive there. All right, sec of 271. Now, it might be helpful to remember, which is sec the upside down of? Sec is the upside down of which one? Cos. And which quadrant? Where are we? Quadrant 1, 2, 3, or 4? We're in quadrant 4. Is cos and sec positive or negative in quadrant 4? Positive. So the final answer? True. All right. Cosec. Cosec of 170. Let's get an answer from someone. Just put your hand up. Cosec of 170. Right here, Jabulala. You say it's false. Okay. I want you just to tell me which quadrant is 170 in? No, the same letter. Keep the microphone. Quadrant 2. Halala. And cosec is the upside down. Keep the microphone. Cosec is the upside down of which one?
Of sine.
Sine.
Which sign? Yeah. So cosec and sine, are they positive or negative in quadrant 2? Positive. Okay. So in fact, the answer is true. Take a sweet anyway because you've been engaging. Right. Cot, guys. Cot is the upside down of which ratio?
Of tan.
Of tan. And which quadrant are we in? We're in quadrant 3. And is tan positive or negative in quadrant 3?
Positive.
What? Tan, guys, is positive and cot is positive. True. Okay, and the last one, let's just get a straight answer from this guy over here with his hand up, with the isicholo on.
False.
False. Halala. Cos of 200, guys, we over here, and cos of 200 is false. Cos of 200 is not positive. Okay, now, what I want us to do now, okay? I want you to answer these questions. And there's only one answer. Eli Lodwa, there's only one correct answer. All sine, tan, cos. Which quadrant are we in? Okay. If sine is positive and cos is negative. Okay, I don't want you to shout out. I'm going to take some answers now. This is quadrant 1. This is quadrant 2. This is quadrant 3. This is quadrant 4. Yeah. Okay, yes. Yes. A D or B? 2D. This one. Okay, so it's saying cosec of 170. Which quadrant are we in at 170? Quadrant 2. Okay, so we're in here. Now cosec and sine are upside downs of one another, and they are both positive in quadrant 2. And so I have got this wrong. Thank you very much for correcting me. Okay, this should be false. Halala. Okay. Right. Thank you. Okay, guys. I want some answers here now. Remember, and, the word and means both. Both things have to be true. There's only one place where sine is positive and cos is negative. Who can just put your hand up and yeah, there we go. Quadrant 2, well done. Okay, where is sec positive and tan negative? Now remember, I'm going to write this, guys. I'm going to write sec and cos. I'm going to write sine and cosec. And I'm going to write cot and tan. They behave the same way, because when you turn it upside down, the sign doesn't change. Yeah. Okay. Well done. Halala. Okay. All right. What about if sine is positive, quad what tan is negative? Sine, there we go. Here we go. Just in the nick of time. Well done. Hala. All right. What about if tan is positive and cos is also positive?
Quadrant 1.
Quadrant 1.
Quadrant 1. Okay,
Yes.
sorry, I read it on the microphone here. Yeah, on this. Okay. All right. Hala. All right. Cosec negative and cot negative.
Quadrant 3. Quadrant 3.
Sorry. Cosec negative and cot positive.
Is
I'm hearing an answer online. Someone's telling me online quadrant 3. Are they right? Yes, they are right. Well done. Okay. What about tan negative and sine positive?
quadrant 2.
Quadrant 2.
Quadrant 2.
I'm waiting for an answer in the room, and I don't know if people can hear the online learners, and I'm not sure why I'm still hearing the online learners because I shouldn't be. All right, I'm just going to mute them again.
That's on.
Quadrant 2. Hala. Okay. I'm just going to mute this participant too. Okay. Right. Quadrant 2, guys. Tan, and in fact, I've just seen now, does anyone notice this question here and this question here? It's the same question. Okay. I've just swapped them around by mistake. Okay. All right. So I didn't mean to ask the same question. Now, what we're going to do now, okay, we're going to try and do these, and some of them we're going to need to use a calculator, some of them we won't need to use a calculator. What we're now wanting to find is what is the angle if the ratio is a half. Okay, so we're going the other way now. I'm not saying what is the sine of 30 or the sine of 60. I'm saying which angle gives me a sine of a half. Now, if you can use the diagrams, but I'm happy for you to use your calculator. All you're going to do is you're going to use this button on your calculator. This button, okay, and I'm going to explain what that means. It means undo. It's also in maths called the inverse. Okay, who can tell me what's the undoing of adding 5? How do you undo adding 5? You minus 5. How do you undo timesing by 3? You divide by 3. Halala. And these things we use when we solve equations. How do you undo squaring a number? How do you undo squaring? In other words, if you square 3 and you get to 9, what do you... Yeah, it's called that. I'm seeing this learner here is drawing it for us. It's a square root. Okay, halala. These are undo operations of one another. And here we've got sine and sine with a little minus 1. Now, don't get confused, okay, because it can be confusing. Maths is sometimes a little bit confusing. When I write 2 to the minus 1, that means 1 over 2. You remember your exponent laws? And if I write x to the minus 3, it's 1 over x cubed. Chord 1. When I've got sine with a minus 1, it is not cosec. It's not 1 over sine. It means undo. Okay, so on my calculator now, if I undo sine of a half, all right, so I'm going to go shift sine of a half. I get 30 degrees. Okay, and I'm just going to show you on here again. I'm going to show you on here. Guys, if I go to 30 degrees, look here, if I go to 30 degrees, 30 degrees. If I go to 30 degrees, what do you see about sine? Sine is a half.
Positive.
Okay, well, it's positive, but it's actually a half. Okay, all right. Now, cos of root 2 over 2, cos of an angle is root 2 over 2. What is the angle? Okay, we just do these ones together. Okay, it will be 45 degrees. Tan of theta is 1. What is the angle? It's 45 degrees. Okay, remember, if I go back to my triangle, tan of 45 is 1. Or Norma, if I go to my Cartesian plane, tan of 45 is y over x, it's root 2 over 2, it's 1. Okay, Nancy Kinga. Cot theta is root 3. We have a problem, okay, because our calculator, guys, listen carefully, our calculator cannot do cot, it cannot do sec, it cannot do cosec, it cannot undo cot, cosec, or sec. Look at the calculator. There's just 3 things the calculator can do: sine, cos, and tan, and it can undo them. Okay, now, Nancy Kenya, because my calculator can't undo cot. Cordwell, what can I do to this side? What if I make this tan? What have I done? I have turned it upside down. Okay, so if cot theta is root 3, then what is tan theta? Turn this upside down as well, guys. It's 1 over root 3. Now, the problem is fixed because I can use my calculator to undo tan. Who can tell me what happens when I undo tan of 1 over root 3?
0.0.
Undo tan. Don't find the tan of 1 over root 3. Undo tan. So I'm going to go undo tan of 1 over root 3. I get 30 degrees.
Yes.
Okay. That's in King of 40. Okay. I'm going to turn sec upside down and I'm going to turn 2 over 1 upside down. What will the next line be? Guys, what's the upside down of sec? Do you see how you need to learn these ratios? The upside down of sec is cos. And the upside down of 2 is a half. 2 over 1, 1 over 2. Now, if I go undo cos of a half, I get 60 degrees. Okay. Sine theta is root 3 over 2. This one's easier. I could just undo sine of root 3 over 2. It's a special angle. It's also 60 degrees. Guys, I hope you're following. Okay. This one, I've got to use a calculator. I don't know. I know that sine of 30 is a half. This is going to be a bit more than 30. Maybe this is going to be 40, guys. Who can tell me what is it? Let's get 1 decimal place. So someone just put your hand up. 1 decimal place. Sine. I want your answer. With the microphone.
0.
Okay, I'm going to have a look. The only reason I'm having a look, I want to check that you know how to round properly. Okay, you're 100% correct. It's 35,2. Guys, because remember, if we go to 1 decimal place, we must look at the second decimal place. If it's 5 or bigger, then we must round up to 35,2 degrees. Okay, I don't know if you've seen, guys, I keep underlining my answers. All right, it's a good thing to do. All right, who can tell me what if tan theta is 2,4, what's theta? Someone, let's have also to 1 decimal place. 67,4 degrees. I'm just going to check it. I'm going to go shift tan
2 decimals.
2,4. 67,4. Well done. Okay.
1 decimal.
Now, guys, this one here, I'm going to have to use my calculator. I'm going to go sine theta because I'm going to turn cosec upside down. This is going to be 1 over 2,145. I don't need to work this out. On the next stage on my calculator, I'm going to undo sine of this stuff of 1 over 2,145. Let's have a look. Undo sine shift sine 1/2,145. Can I just get a show of hands? How many of you have not got a calculator, that you don't own a calculator? Everyone got one? 27,8. Well done. 27,8 degrees. Okay. Right. Okay, now, guys. Now, this is where it's going to get slightly more interesting. We're going to go to page 6. Okay. And we are going to draw a picture. Okay. Because we are in the Cartesian plane, we are only going to use X, Y, and R. Okay. Now, I want to tell me, which quadrant am I in for this question? And we've answered questions like this. We know that cos is negative 2/3 and sine is positive. There's only one quadrant I can be in. I'm going to draw this again to remind you, all sine, tan, cos. Which quadrant am I in? Cos, well done, halala, I'm in quadrant 2. Okay, and guys, I'm in quadrant 2 because that is where cos is negative and sine is positive. I want you to keep the microphone, okay? I want you to tell me, what is cos? Is it r over y? Is it y over x? What is cos?
A over H.
I'm hearing online someone saying adjacent over something. I don't want it like that. Okay, I want it with x's, y's, and r's. Halala. Okay, now guys, what I'm going to show you is that, remember, r is a length. So this minus 2/3 is actually minus 2/3. The x is negative and the r is positive. So we're going to draw
the hypotenuse is always positive.
This is 3, and this x value is negative 2. Okay, is everyone okay with that? The r value is 3. The r is always positive. The x value is negative 2. Notice that the minus is written there. The minus can be written anywhere, but in fact, it's actually negative 2. Now, guys, that's negative 2 because we're in quadrant 2. This as a length is 2. Who can tell me, how can I work this out? How can I work out this y value? I'm going to use the theorem of Pythagoras, okay? I'm going to square 3. I'm going to square 2. I'm going to subtract them. And I actually get the square root of 5. Is it positive square root 5 or negative square root 5 if we're in quadrant 2? Halala, it's positive square root 5. Okay, now. Okay, now see, I've been muted. Okay, the problem is if someone makes a noise, then it mutes my microphone, and then no one can hear me. Okay, I'm just going to try this again. Meeting options. Allow mic for attendees. I'm actually going to turn that off as well. Save. Okay, I'm hoping we don't hear anyone. Okay, right now, guys, it asks us for the other 5 trig ratios. Now, so let's write them down. We were given cos. What is sine? Sine is y over r. So what will sine be? It will be root 5 over 3. Cos we've got. Let's do cosec quickly, because cosec is easy. Cosec is just the upside down of sine. it will be 3 over root 5. What about tan? Or let's do tan. Tan, guys,
y over
is
x. Y over x.
Well done. It's root 5 over negative 2. Do you see how important it is for us to learn our ratios? How do I get cot from tan? What do? I turn it upside down. Negative 2 over root 5. And the last one that I haven't got, who can tell me which one am I missing? There's cos, but which one have I not got? I haven't got sec. How do I get sec? I turn cos upside down. So 3 over negative 2. Okay. Right, now I want to show you how we're going to find the size of this angle here. Okay, and I'm going to show you something that's very important for how we do trig later on. I'm going to find what I'm going to call a key angle, ukiye. Okay, and the way I find a key angle is I put the ratio in, but I don't put the negative value in. I want to show you if I go shift cos of 2 divided by 3, I'm not putting the minus. I get 48,2 degrees. If I go shift, let's go shift sine of, I'm doing sine of the square root of 5 over 3. I get 48,2 degrees. If I go shift tan, I'm not going to put the negative in, guys. If I go shift tan of the square root of 5 over 2, I get 48,2 degrees. 48,2 degrees is my key angle. Okay. And the way I find a key angle is I undo the ratio, any ratio. I undo any of the ratios using the positive value. Okay, the reason I haven't written the word positive, I'm going to change pen color. I want to write it in red. Okay, you might not be able to write it in red, but I want you to underline it. Okay, we put the positive value in. All right, so for example, I can go, my key, I can undo cos of 2/3. I'm not putting the negative in. Or, Norma, I can undo, let's undo sine of root 5 over 3. Okay, and I get 48,2 degrees. Now, guys, this is not 48,2 degrees. You can see this angle here, theta, is not 48,2 degrees. What we have found is this is the amount off the horizontal axis of 180 into quadrant 2. So in other words, theta is actually going to be 180. This angle here, guys, is 48,2. So everything's connected. Angles on a straight line add up to 180. So 180 minus 48,2. And I get theta. My final answer for theta is 131,8 degrees. Okay. I want you guys to try B. Now, I'm going to give you a little hint for B. How can I write -2 as a fraction?
-2 over 1.
Well done. -2 over 1. I'm hearing online. That's fine. I'm still hearing online people. That's cool. All right. I'm just hoping that I'm still being heard. Yeah, I am. Okay. All right. I want you guys to try and do question B. But the first thing you need to ask yourself is, which quadrant? Okay. You can talk to the person next to you. And if you've managed, I want you to draw it. I want you to work out where theta is. All right. You'll see there's quite a lot of them. We might do 3 of them. We won't do 4 of them, I don't think. We'll leave one for you to try over the weekend. Work out which quadrant are we in, okay, and then take it from there.
Quadrant 3. Quadrant 3.
Okay, so I'm hearing someone online and they're saying quadrant 3. I don't think it's quadrant 3 because tan's negative here and tan is positive in quadrant 3. Remember, here's quadrant 3. Guys, yeah, I'm definitely in quadrant 4. For B, I'm in quadrant 4. Okay. The next thing you need to do is you need to work out what's y and what's x. Okay. Okay, who can tell me? Yeah, who can tell me what is x and what is y? Just put your hand up and let's get the microphone. You're in the back row here. I under sort of somewhere along there. Just cruise along the back row here. Put your hand up again. What is x and what is y? Yeah, this learner over there's got their hand up in the back row. Oh, sorry, someone's here. Sorry. Okay, that's fine. What is x and what is y? X is minus? No. Remember, what is tan? Guys, this is, if you need to know your ratios, what is tan? And I want you to use x's, y's, and r's. Tan is y over x. So which one's negative in quadrant 4? The y value. So what's the y value and what's the x value? Well done. Y is minus 2 and x is 1. Well done. 1 minus 2. Now, guys, I want you to look where I've drawn this line. I did not draw it over here because over here, the x value would be bigger than the y value. Okay, I've drawn it over here because this is going to help me realize what the size of the angle is. What do I still need to, if I wanted sine of theta, what am I missing? Which of these variables am I missing? I'm missing r. Who can tell me what is r going to be? Okay, and I'm going to suggest that we use Pythagoras again. This is 2, this is 1. What is r? No, r is not 2. Guys, this is a right angle triangle. This is 1, this is 2. No, not 3. Pythagoras. It's not 4.
I said 5.
Okay, not 5. It's the square root of 5. Guys, 2 squared is 4 plus 1 squared, 1. 5.
Yes, it's 5.
Okay. So now, what is sine theta going to be? And you can only do this stuff, guys. You can only do this if you have learned your ratios. Sine is y over r. 2 over root 5. What's the upside down of sine called?
It's
Guys, what's the
5
upside
over
down of
2.
sine called? What's the upside down called? Cosec. Well done.
Cosec, yeah.
Okay, let's do cos. What is cos? Cos is what over what?
It's x over y.
Cos is not x over y. I'm sorry. The lady who answered online. Cos is not x over y. What is cos? We need to learn this, guys.
X over r.
Yeah, cos is x over
over r.
X over r.
X over
So, what is the cos of this angle here? It's x over r. It's 1 over root 5.
E.
Sec is just the upside down of
Cos.
So it's root 5. Yeah, it's r of x. It's root 5 over 1. It's just root 5. Okay, and the last one that I haven't got is cot. Now, cot is just the upside down of tan.
Tan.
So turn negative 2 over 1 upside down and we get negative 1 over 2. Okay. This is easy if you know your ratios. If you don't know your ratios, it's impossible. You can't do it. Right, now, I want to remind us where theta is, guys. Some people think theta is here. They are wrong. Some people think theta is here. They are wrong. Okay. Some people think theta is here. They are wrong. Where do we start? We start here. And we go all the way around there. And I want you to draw that on your diagram. That is theta. Okay? Now, what we're going to do now, we're going to find theta, but first we are going to find a key. Who can remind me what's important when I find a key? I'm going to undo the trig ratio. Let's choose one of them. Let's undo tan. But what mustn't I do? I must use the positive value. So I can tell you, because I've been teaching for too long, that when you undo tan of 2, you get 63,4 degrees. Okay. You can check if you don't believe me, you can check on your calculator, but it's 63,4 degrees. Okay, now, guys, this angle here is not 63,4 degrees. This angle here is 63,4 degrees. So, what will theta be? Look, we want this one, and we've got the other piece that's inside the angle around a point. So, theta will be 360 minus 63,4. All right, and that comes to 296,6 degrees. Are we okay? All right, we're going to do one more of these questions, just one more. All right, so I'm not going to do both of these. Let's do this one. In fact, yeah, let's do this one. Okay. The first thing I'm going to do here, because I'm not really a big fan of sec, how do I change this into either sine or cos or tan? What will it be? It will be cos. Well done. What have I done to go from sec to cos? I've turned it upside down. So I need to turn minus 2 upside down. What is minus 2 as a fraction? Yeah, minus 2 as a fraction is minus 2 over 1. When I turn it upside down, minus 1 over 2. Okay, I want you to try and finish this one now. So in other words, I want you to tell me, I want you to draw the sketch, I want you to label theta, I want you to tell me what is the sine of theta, as well as the upside down of sine, which is called cosec of theta. I want you to tell me what is the cos of theta, as well as the upside down of cos, which is sec of theta. I want you to tell me what's the tan of theta, and I want you to tell me what is the cot of theta. Now, one of them I've already been told. Okay. Sec of theta is minus 2. Cos of theta is minus a half. Cordra, I can't do the other ones until I know what I'm missing a variable here. Right. The first thing you must decide is which quadrant are we in? I don't think we're in quadrant 4. Okay, guys, all sine, tan, cos. We want cos to be negative. Quadra, we want tan to be positive. Hala, we're in quadrant 3. Okay, now, what is cos? Is it r over y? Is it y over x? Is it x over r? Is it x over y? What is cos? X over r. Okay. Is the r positive or negative? Guys, r is always positive. So it's actually -1 over 2. 2 is quite long, so it's like there. Just try and draw that straighter. So this is 2. Okay. What is x, guys? X is -1. That means that this distance here is 1 as a distance. R is 2. So now I've got to work out my y value using Pythagoras. Okay, and so I'm gonna write y here. In fact, I'm not gonna write y there. Guys, you can tell me the size of y. You can just shout it from the back. Just shout it out nice and loud. Well done. The square root of 3. Cordra, is it positive square root of 3 or negative square root of 3? Yeah, man. Guys, it's negative. This distance is the square root of 3. Cordra, we are in quadrant 3. It's negative the square root of 3. The reason learners get these questions wrong, listen carefully, is because they are working in the wrong quadrant. Okay, we are in quadrant 3 and y is negative. Now it's easy. As long as I know my ratios, what will sine be? Sine, remember, is what over what? Sine is? Yeah, guys,
Y over
hearing
y
some of
over
you saying
R.
opposite and hypotenuse, you're right, but in the Cartesian plane, let's use y, x, and r. It's y over r. So it's going to be negative root 3
Over 2.
over 2. Hala. Cosec is just the upside down of sine. So it's going to be 2 over negative root 3. What about tan? Tan is what divided by what? Y over x.
It's
Guys,
y over.
it's going to be negative root 3
Over 2.
over negative 1. And that is positive root 3. Did we expect tan to be positive in quadrant 3? Yes. Okay. And remember, what will cot be? It's the upside down of tan. It'll be -1 over negative root 3 or just 1 over root 3. Okay. All right. Now, what we're going to get into now is we're going to find missing sides and angles in triangles. But I want to show you a little video, okay? And I've got this thing over here. It's a very simple thing. And I think, unfortunately, I think the people who are online are not going to be able to see it, okay? So what I did is I made a little video to show you. But it's got a little tube here. In fact, you know what? I'm just going to show you the video and then everyone can see. All right. Now, I made this video during COVID, okay? So it was in 2020, and during COVID, you weren't allowed to go to the hairdresser, to the barber. So this is me in 2020, okay? Just listen carefully here.
With this, the right hand straight down and up and end of 0. I was hoping it's going to get after something, and then it will get to that angle of introduction. So, for example, there are, you know, I'm standing on the second distance, which I know, away from the right interval, and I'm looking focusing on the top of the right interval.
I'm looking at the same.
Get back to you. Right, thank you.
Okay, so what that little thing does is it allows us to work out what we call an angle of inclination or an angle of elevation. I want to go back to this page in your notes, and I'm sorry there's a bit of a mistake here, because what happened is that this was on the previous page, and on page 3 you'll just see a picture of Inyoni. Okay, so I want you to go to page 4. All right, and I want you to draw the Inyoni over here. Okay, I'm not very good at drawing, so I'm just going to draw this as a bird in Inyoni. It's flying. Okay, now guys, when we look up at an angle, that's called an angle of inclination or elevation. Okay, and when we look down, it's called an angle of depression. Okay, so down off the horizontal is depression, up is inclination or elevation. Okay, and what I've just realized, and I don't know what made me think of it, the previous question, we did not finish the previous question. We never found theta. Okay, so I'm gonna leave that. I'm just gonna quickly finish this question here. Guys, I want the angle. Now remember where theta is. Theta's not here. Theta's not here. Sorry, I'm on page 6. Page 6. Theta is from here all the way around to there. Okay, now I'm going to find a key angle. And the key, when I find a key, is I'm going to undo any one of these ratios. Cordwa, I'm going to use the positive. So I'm going to undo cos, but I'm not going to do minus a half, I'm going to do plus a half. All right, and when I do that, I get 60 degrees. Now, guys, this here is not 60 degrees. We can see it's not 60 degrees. Who can tell me what must I do to get theta if this is 60 degrees? 60 degrees is my key. I mustn't minus it from 360 because then I'll be in quadrant 4. I must add 60 to 180, guys. This is where the 60 is. Okay, so theta is 180 plus, no, not minus. If I go minus, I'm going to be in quadrant Q. 180 plus 60. Theta is 240 degrees. And I can check on my calculator with that's right. I'm just going to show you. If I find the sine of theta, the sine of 240, I get negative root 3 over 2. Okay, if I find the tan of 240, I get the square root of 3. And that's what we got over here. Okay. All right. What we're going to do now, I'm going to leave number D here, guys. All right. You could try it at home. What we're going to do now, we're going to finish before we go to T by looking at solving some triangles. Okay. Now, before we solve some triangles, I want to tell you about the semi rule. Okay. The semi rule. Now, what the semi rule says, I'm going to just quickly show you, and you don't need to go there. It says that when we've got a triangle, the biggest side must be opposite the biggest angle. It says that the smallest side must be opposite the smallest angle. And it says that the middle-sized side must be opposite the middle-sized angle. Now, I'm going to show you a sketch of this, just to help you remember it. Okay. There it is, in fact. Guys, I want you to look at this. Which is the biggest angle in this triangle? The blue one. And which is the biggest side? The blue one. Which is the smallest one? The green one. Okay, and the smallest angle, the green one. Notice when I drag this around, okay? All right, I'm going to make the blue one the smallest. Do you see? Okay, the blue one's not the smallest. Yeah, the blue one's the smallest. Okay? there's the side lengths. Okay, something's the blue one's not the smallest. Sorry, I'm going to make the blue one the smallest. I'm going to try and make the blue one the smallest. Okay, do you see the blue one is the smallest angle? Okay, and the blue side is the smallest side. Which is the biggest angle now? The green one. And the biggest side? Okay. The biggest side is always opposite the biggest angle. The smallest side is always opposite the smallest angle. Right, so now we're on page 7. Okay. Page 7. And this is the last thing we've got to do, right? We've got to try and find the missing sides and the missing angles. Okay, so the first thing that I think is going to be very easy. What will angle A be, and how do we know that? It's going to be 68 degrees. Why?
Because 60.
Angles of a triangle. This is geometry. Mind you, we're doing trigonometry. Okay, everything is connected to everything else in maths. Now, I want to find one of these other sides. I'm looking for someone, and I definitely think this is going to deserve a sweet, so I'm looking for the microphone as well. Who can tell me a trig ratio which is going to allow me, and so I want a little equation. Remember, an equation has an equal sign. I want something, the sign of something equals wada, or cos of wada. Okay, who can tell me? All right, and now, guys, now we are using op, height, and adjacent. We are not in the Cartesian plane. We're not using x, y, and r anymore. We need to learn both the definitions. All right, who can tell me? $22. Just 22 or a ratio? Yeah. But I know that already. Okay, thank you. But I know that. I know that this is 68, and we've got that. Okay. I want someone to use a trig ratio. Use a trig ratio, either sine, norma cos, norma tan, okay, which is going to allow me to find one of the other sides, either AC or BC. Okay, so someone else, put your hand up. Yeah, there we go. There's a letter there. I think it's from, is that from Shea? Shea Connor? No. Sine of what? 22 will be what? It'll be AC over AB, and I know what AB is 17,2. Hala. Okay, guys, can you see why this is? Remember, sine is opposite over hypotenuse. How many things don't I know here? How many variables are left in this equation? Elilodwa, just one. Who can tell me what must I do now to find AC? What should I do to both sides of the equation to find AC? I want to get rid of this dividing by 17,2. Well done. I'm going to multiply by 17,2 on both sides of the equation. Now, I can get the answer for AC. It's going to be 17,2 multiplied by the sine of 22. And I get 6,4. All right. The question says to one decimal place, 6,4. Okay. It's actually 6,44, but one decimal place, 6,4. Now, I know that this is 6,4. I know that this is 68. Who can tell me, and there's two different ways, who could tell me one way that I could find BC? Well done. I could use the theorem of Pythagoras. Well done. Cordwa, what else could I do? I could use a different trig ratio. Which trig ratio will involve the adjacent and the hypotenuse? Well done. I could use cos of 22 is BC over 17,2. 17,2. All right. And what must I do to both sides to get BC? Times by 17,2. So this time I'm going 17,2 degrees cos of 22. Sorry, not 17,2 degrees. Not 17,2 degrees. So this is not degrees. I call it. Yeah. All right. Okay. Guys, this comes to 17,2 times by the cos of 22. And I get 15,9. 15,95, but we're just going to one decimal place, 15,9. Okay, now, I want us to check. Has the semi rule applied here? Is the biggest side opposite the biggest angle? Yes. Is the smallest side opposite the smallest angle? Yes. Okay. If the semi rule is not applying, you are wrong. Okay, I promise you, you are wrong. Okay, so what we've done here, we've used our trigonometry to find missing sides and angles. Okay, we're gonna do another one now. All right. Who can tell me what could I do straight away, no trigonometry, to find this length over here? I could use the theorem of Pythagoras, okay? I could square 8, I could square 15, I could add them together and I can square root, okay? And I'm going to tell you that you get 17. Man, not 17 degrees, 17 centimeters. Okay, now, guys, now I'll sing a keta because I want to find one of these angles, okay, using trigonometry. So who can tell me how I can find angle D? This angle over here, I want a trig ratio. And I'm saying you can choose, because I know all three sides, you could use sine or cos or tan. Okay, so put your hand up if you can tell me how am I going to find the angle D? Right. So I'm wanting a little equation, either sine of D or cos of D or tan of D. This is easy if you have learned your definitions. If you know that sine is opposite over hypotenuse, cos is adjacent over hypotenuse. Guys, if I hold something up like this and I say, yinile, what is this? It's a phone. If I hold this up and say, yinile, it's a cup, inkomishi. You don't have to think about that. If I say to you sine, you must say opposite over hypotenuse, y over r. If I say to you tan, you say opposite over adjacent, y over x. Okay, right. Who can tell me? Put your hand up. I want a trig ratio of D equals something over something. Yes, over there, right at the end. Yes. Cannot be that cold. Okay, right. So I just went to see if there was a door open. There's a freezing cold wind blowing through here. Okay, who can tell me what is it going to be? Tan of D. Hello, well done. Okay, all right. Guys, do you see that we could have used sine of D. Sine of D would be 15 over 17, opposite over hypotenuse. We could also have used cos of D. Guys, what would cos of D be? It would be 8 over 15. Hala. Now, I can use my calculator. I must undo tan. I'm going to undo tan of 15 over 8. Let's have a look at what that looks like. Undo tan. Shift tan of 15 over 8. Okay. Oh, wait a minute. Okay, I didn't undo. Shift tan. 15 over 8. 61,9 degrees.
Yes.
Now I want to find E. I could use a trig ratio, okay? Or no, I could just use angles of the triangle. Angle E is going to be 61,9 plus 90, add those two together and subtract from 180. It's going to be 28,1 degrees. Okay, 28,1 degrees. I want to ask you, has the semi rule been followed? 28,1, 61,9. Is the biggest side opposite the biggest angle? Yes. Is the smallest side opposite the smallest angle? Yes. Okay. All right. So guys, we're not going to have time to do all these questions. All right. I'm going to leave a couple of them for you to try over the weekend. All right. But I want us to go now. Okay. I want to show you something here. Just at the bottom of the page here. Who can tell me the missing sides and angles in here? What size is angle M? 90 degrees. Why? Angles of?
The triangle adds up to 180.
80
Well done.
degrees.
Who can tell me what is MN equal to?
And
At this side.
it's equal to MO.
It's equal to MO, guys. It's equal to 60
Yes.
centimeters. And the reason for this is these are sides
Opposite.
opposite equal angles. This is what we call an isosceles triangle. Okay. And then, could I work out NO? Yes, I could work out NO using Pythagoras. I would square 16. I would square 16. I would add them together and I would square root them. And I get the square root of 512. Okay. And guys, it's going to be about 23, maybe. Let's just see. I'm guessing. Square root of 512 is about 23. It's 22,6. Not too bad. Okay, guys, the reason my mental arithmetic is good is that I try and use my brain rather than using a calculator. Okay, this question over here. Can I use opposite over hypotenuse, opposite and hypotenuse and adjacent? Can I use that? Okay, guys, I cannot use my trig ratios. Okay, why not? There is no 90-degree angle. All right, this question is impossible for grade 10. You could work out this angle, yeah, but you can't work out the other sides in grade 10. Okay, this question here we will learn to do in grade 11. Okay. All right. Now, I want us, the last questions we're going to do before we go to T, all right, we're going to just look at some sort of word problems. And we're only going to do 2 of these, all right? Okay, so a boy flies a kite. Here's the boy. Okay, and he's flying a kite. Here's the kite. right? And the string is 67 meters. The kite is 40 meters above the ground. Okay, so this is 40. And then it says, what's this angle over here? Okay. Have I got a 90-degree angle? And if so, where is the 90-degree angle? Where's the 90-degree angle? Is it here? Is it here? Is it here? Yeah, it's over here. All right. Now, guys, who can give me an equation using a trig ratio? Something of theta equals something over something. So I want to find theta. So I want some trig ratio is something over something. Which one can I use? Guys, I can use sine. Can I use cos? I can't use cos because cos would be this over this. And I don't know this and I don't know this. If I use sine, what will it be? Sine of theta will be what? Yeah, and so what will it be? Put the numbers in. 40 over 67. Hala, hala. Now, can I work out theta? Yes. What button must I use on my calculator? Shift sign, undo sign. All right, and let's see, what do I get?
It's 36,6.
Well done, 36,6.
Yes.
Shift sign of 40 divided by 67. 36, if we round it to one decimal place, actually 36,7 degrees.
Yes.
Okay, well done. Right, now, excellent, guys. Now, I want you guys to try and draw the picture for number 8. And this is the last thing we're going to do, and then we'll take a tea break, okay? Okay, the picture for number 8. I want you to try and draw it, and I want you to tell me how long is the cable. So we've got a tower. Here's the tower. Okay, I can't really draw very well. That's why I'm a maths teacher, not an art teacher. If I could draw, maybe I'd be an art teacher. Guys, there's the 90-degree angle. All of these questions have got a 90-degree angle in them because we can only do it if we've got a 90-degree angle. We've got a cable. And the cable makes an angle of 40 degrees. What's the other piece of information in this question? What else do I know? 97. Where's 97? Here, where?
97.
97 is the tower. Okay. Which trig ratio can I use to find out how long is this cable? The sine of 40 will be what over what? It will be 97, it's opposite over the hypotenuse. 97 over the cable. Okay, now this is just an equation. What's a little bit ugly here is that we've got a fraction. What can I multiply both sides by to get rid of the fraction? By cable, yeah. So
Multiply by 30.
cable times by sine 40 is going to be 97. What must I do to both sides to get the cable? Divide, well done. Cable's being multiplied by sine 40. I must divide both sides by sine 40. So my final answer is going to be 97 over the sine of 40.
Can you please repeat? Can you please repeat for us?
Yeah, so I'll just go from the top here. Sine of 40 is
Yes.
the opposite, which is 97, over the hypotenuse, which is the cable. Now,
Yes.
the problem here, okay, the problem with this question as it stands, I've got a fraction, okay, but if I can multiply both sides by cable, then the fraction is gone. Okay, much better. And now I want the cable. And the cable times sine of 40 is 97. So I want to get rid of the sine 40. Cable's being multiplied by sine 40. The undo of multiplying by sine 40 is dividing by sine 40. And I'm dividing by sine 40 on both sides. And I get my final answer that the cable is 97 over sine 40. Right.
Thank you.
Sure. 97 over sine of 40. And I get 150,9.
Oh.
150,9 meters. Okay. I'll show you because I think it's very clever how we can use trigonometry to calculate the height of something. Okay. So in question 10, and I don't know what happened to question 9, there isn't a question 9, but in question 10, we've got a tall tree. Okay. Okay, as I said, that's why I teach maths and not art. Now, maybe there's other stuff here, and we can't get to the top of this tree. This could be a mountain even. Okay, whatever it is. But, and listen carefully to this, a man looks up at an angle of elevation of 50 degrees to the top of a tree. Okay? Now, when he walks a bit closer, the angle of elevation changes to 60 degrees. We can see that it gets bigger. And all we know is that this is 5 meters. Now, I want to show you how we can work out the height of the tree. We don't even need to get anywhere near the tree because this is the right angle in here, okay? All right. Now, what I'm going to do, and this is a little bit tricky, but I think you guys are up for it, okay? And it's important for me to show it to you because it's a nice application. Because I don't need to be able to get to the bottom of the tree. Okay? If the tree is h, the height of the tree is h. And if this distance here is d, from here to here, is everyone okay that tan of 60, remember tan is opposite over adjacent. Tan of 60 is opposite over adjacent. So tan of 60 is going to be h over d. Now, Nansinkinga, because there are two variables. Kodwa, what do I know about tan of 50? Tan of 50, guys, tan of 50, and I'm looking at the big triangle now, tan of 50 is going to be h over, what's the adjacent? What's this total distance here? It's d plus 5. Okay, now, here's an equation, but it's got two variables. Here is another equation. It's got two variables. Can anyone tell me what we're going to do to try and solve for these two variables? What do we do in maths when we've got two variables and two equations? Say it loudly. Well done. Simultaneous or simultaneous equations. Okay. what I'm going to do with number 1 is I'm going to multiply both sides by d. If I multiply both sides by d, I won't have any fractions, and I will know that h is d tan 60. I'm going to do that with number 2 as well. H is going to be d plus 5 times by tan 50. Now, both of these are h, so I can make them equal to one another. I can say d tan 60 is d plus 5 tan 50. How many different variables are in this equation? In this red equation? There's only one variable now. There's only d. Okay? Elilodwa. So I can solve this now. Now you're probably saying, sure, how are we going to solve this? I don't like these brackets. So I'm going to multiply the tan 50 by both terms inside the bracket. So I'm going to get d tan 60 equals d tan 50 plus 5 tan 50. Which variable am I trying to find? I'm trying to find d. What can I do to get this onto the left-hand side? I can subtract d tan 50 from both sides. Are we okay? D tan 60 minus d tan 50 equals 5 tan 50. Okay, we're nearly there with this question. I want to see if anyone can tell me, how am I going to sort out my d is in 2 different places? What mathematical trick, what technique can I do to just get d in one place? Guys, could I take it out as a common factor? Well done. So I now tan 60 minus tan 50. And what's the last thing I'm going to do to both sides to get d? I'm going to divide by this stuff. Now I'm going to leave d here, and I'm going to divide both sides by that whole bracket. Okay? In other words, by tan 60 minus tan 50. I'm going to go to my calculator. I'm going to work that out. 5 tan 50 over tan 60 minus tan 50. And I get the d is 11,03 meters. Now, I want to know how tall the tree is. So now I can substitute this value back into one of these equations. There, the height of the tree is d tan 60. We can see here's an expression for the height of the tree. So h, I can work out h is going to be 11,03 times the tan of 60. Okay, and I can just do that on my calculator. There's that number times by the tan of 60. I get 19,1 meters. Now, I'm hoping you appreciate this. This is quite clever because I didn't ever get to the base of the tree. All right, I didn't even know how far I was from the tree. All I knew was that when I walked a certain distance, I knew the two different angles of elevation. And using simultaneous equations, I can solve this. Guys, we're going to leave trigonometry now, but I want to just tell you one thing, one guarantee. If you don't learn your trig ratios, if you don't know that sine is opposite over hypotenuse, that cos is x over r, that cosec is the upside down of sine, that cot is the upside down of tan, that tan is y over x, tan's opposite over adjacent. If you don't learn that stuff for Monday, you're going to struggle, okay, because you need it all the time. So I'm just going to quickly show you, I'll come back to this page, but on page 1, this table, you need to know that table. You need to know the entire table. If you've got a baby brother or baby sister or anybody, your granny, ask her to test you. Give her the table and then ask her to say cos theta, and you must be able to say cos is adjacent over hypotenuse, norma, it's x over r. Okay, tan is the opposite over adjacent, norma, it's y over x. Okay, I'm going to just leave that sketch up just briefly in case some people are still copying the work in there, and then we're going to look at some geometry. All right, guys. So there's a whole lot of geometry results here, and they're on your page. I'm going to just quickly talk to you about all these results. Okay, and here they are. Okay, so the very first one. What do we know about angles on a straight line? They add up to 180 degrees. Okay, it doesn't matter where the straight line is. They add up to 180 degrees. What do we know about vertically opposite angles? They're equal. Okay. What do we know about angles around a point? They add up to 360 degrees. The green one, the red one, the blue one, and the pink one add up to 360 degrees. Doesn't matter if I change this, they always add up to 360 degrees. What do we know about, okay, now what I've got is I've got some parallel lines that I actually left them in my car because when I show them to you guys, the people who are online don't see. Right, but these lines are parallel. You can see as I move the line, this says parallel, okay? So the lines are parallel. Now, this red angle, and I want to show you what happens when I slide this. Those angles are what we call corresponding angles. Okay, and these green ones are corresponding angles. And these pink ones are corresponding angles. And the blue ones are... Okay, and corresponding angles, guys, are equal when the lines are parallel. They're not always equal, but they are equal when the lines are parallel. Now, we've got these angles over here. Right? These two, this blue angle and this pink angle, they must add to 180. Why? Because they are
Angles on a straight line.
on a straight line. Now, I want to show you, if I move this blue angle and I turn it around, it is called, the pink and the blue one are now called co-interior angles. And notice when it was here, it added with the pink one to make 180. It still adds with the pink one to add 180. Co-interior, together inside. Okay, when I move this blue one from here to here, those blue ones are alternate angles. And the pink ones are alternate angles. Okay, right. The next thing I want to show you is, are these lines parallel? No. What must I make this green angle for these lines to be parallel? It must be what?
In a straight line.
No, if I want the lines to be parallel, what size must the green angle be? It must be 61. Have a look, guys. Ha! Parallel.
It must be
Not parallel. Parallel. Okay, let's just do another one. Okay, so let me just. Okay, what size? I don't know if I can't drag anything here. Okay, all right. What size must I make the blue angle if I want these lines to be parallel? 64. Let's just check. Do you see they're getting more and more parallel? They're not parallel. Ha! They're parallel. 65. I got it. They're not parallel. 64. Ha! Okay, right. So, guys, the lines are only parallel when the corresponding angles are equal or the alternate angles are equal. Right. What we know, guys, what we know about the angles of a triangle is that they add up to 180 degrees. But I want you, listen carefully. I want to know why you know that, how you know that. Okay? You may be going to tell me, Paul, I know the angles of a triangle add to 180 degrees because my teacher told me. Okay, maybe your teacher told you that cows are green as well. Maybe your teacher told you that the sky is yellow. Okay. So I want to show you why the angles of a triangle add to 180 degrees. Okay? Watch what happens when I slide this. Okay? Do you see that red angle and that red angle are the same because they are alternate angles. This blue one and this blue one are the same because they're alternate angles. But what does a blue and a green and a red one add up to? 180 because they're on a straight line. So the ones inside the triangle must add up to 180 also. I'm going to do that again. I'm going to move the triangle just to show you it doesn't matter. Okay, so there's the triangle. Now, when I slide this, I want you to show what's happening here. We're going to put a parallel line across the top of the triangle. Look at this. Those are alternate angles, guys. And you see, if we draw this line parallel, then this blue one is equal to this blue one because they're alternate. This red one is equal to this red one because they're alternate. And what do a blue and a green and a red add up to? 180. Does it make sense? It always makes sense. Okay. What do we know about the exterior angle of a triangle? It equals the sum of the opposite
interior angles.
We can see it there. Okay. All right. The next one, guys. If we've got two sides equal, then the angles opposite them are equal. If we've got two angles equal, then the sides opposite them are equal. Okay. All right. The next one, obviously, if we've got three sides equal, then all the angles opposite them are equal, and we've got what we call an equilateral triangle. But the next one, congruency. These two triangles are identical. Okay, so I'm going to drag this one. I'm going to move this one around. I don't know if I can move this. I can't move this. I can't move this. Okay, but I can move this. And notice that these two triangles are identical. The word identical in maths we say congruent. Okay, even though they are positioned differently, they are identical. When I list them, the order in which I list them is really important. If I go, and I've not done that yet, if I go, listen carefully, C-A-B, CAD, triangle C-A-B, what will it be congruent to? C-A-B. Okay, guys, if I go C-A-B, I must start at L. Guys, look, I started at C. C is the red angle. So I must start at L. And then I went to the green angle. So I must go to
J.
K. And then J. Okay. Right. Now, just while we are here, there are 4 conditions for congruency. Side, side, side. Side, angle, side. Angle, side. And right angle, hypotenuse, side. Okay, hala. Okay, and then the last thing, guys, is similarity. Now, these triangles are similar. If we take, listen, guys, just listen, there's quite a lot of noise. Cooler. Okay, if we take the green side divided by the green side, and the blue side divided by the blue side, and the red side divided by the red side, we get the same numbers each time. Look here. It doesn't matter if I make this triangle smaller. These triangles are what we call similar. The one is just an enlargement, a bigger version of the other one. Okay. They have the same proportions. They are similar. Okay, now I wanted to show you my triangles and my rectangles and things, and I can't do it because the learners online can't see. So last night I made a little video, a very short video, which I'm just going to quickly show you. The parallelogram? Okay, so I'll tell you what happened there. The electricity went off. Okay, but now here, it carries on over here. Okay, so my wife was filming this. Right. So guys, what I want you to be able to visualize those shapes. Now, if you look here, we've actually got, if you go to your page 12, all right, we've got a kind of a table here, all right, and it goes up from the bottom, okay. If we've got one pair of parallel sides, we've got a trapezium. If we've got, listen carefully here, guys, if we've got two pairs of parallel sides, that's called a parallelogram. And it has the following properties. The opposite sides are equal, the opposite angles are equal, and the diagonals bisect one another. They cut one another in half. Now, listen carefully, there's now a choice. You either then go to a rectangle. Now, what a rectangle is, it's a parallelogram with a 190-degree angle. If we make one 90-degree angle, this other one is a co-interior angle. It's got to be 90 as well. And this one here is co-interior. So if you have a look at my parallelogram, and I'm sorry for the people who are not in the room, but here's my parallelogram. As soon as I make one 90, just look at this, I make one 90-degree angle. Do you see that this one must be 90 because they're co-interior? And this one must be 90. So when I make a 90-degree angle in a parallelogram, I've got a rectangle. Okay. Now, this is still a parallelogram. Okay. The other option is to have the sides equal. Okay. But, sorry, the property, the additional property for a rectangle is that the diagonals are now equal in length. When we have a normal parallelogram, you can see that the diagonals are not equal. With a rectangle, they are equal in length. When we've got a rhombus, okay, and a rhombus is just a parallelogram with a pair of adjacent sides equal, next to each other, equal, all right, then we've got a rhombus. It's still a parallelogram. All rhombuses are parallelograms. Not all parallelograms are rhombuses. There's two additional things here, is that the diagonals, they bisect, they always bisect for a parallelogram, but now they bisect at 90 degrees, and they bisect the angles. Right, and then the last one, and it's no coincidence, guys, and I'm talking now, guys, to the men in the room, all right? It's no coincidence that the other ones are all named after boys. There's Ronald, there's Patrick, okay, there's Richard, rectangle, now there's Sally, square. Sally is the only one that's named after a girl, after a lady, okay? This is the ultimate quadrilateral, and that's why it's been named after a lady, okay? And one of the things, if you learn nothing else today, is that ladies are special and they deserve to be treated specially, okay? All right, always with respect, okay? So Sally square is the best of the quadrilaterals. Sally, she is a rhombus. She is a rectangle. She is a parallelogram. She has all of them. And because she's all of them, she has all of the properties of all of them. Okay. So Sally's properties are all of the below. Okay. Now, here I've got a picture for you on the next page, on page 13, and it shows you the properties of each of these shapes. Okay, there they are. Right, we're going to come back to them. I want you all quickly to do question 1. Okay, while you're doing question 1, you'll see that it asks for reasons. Okay, so I'm going to play you my song, one of my songs. All right. Do you know what the song is? You do know what it is. I don't know how you know what it is. Okay, here's the song I'm going to play you. No. What's going on here? Try these questions. Okay, this is the, listen here. Just give me a reason. Okay, so what she says is, just give me a reason. Shall I let it carry on? Okay, I'll let it carry on while we do these questions. Okay, right. So guys, I want to know the size of B, and I want to I want to know the size of A and B, and I want reasons for both of them. Who can, and I'm going to ask Ayanda to go around and get some answers for us here. What size is angle A and why?
Sixty-one.
Okay. Why? Okay, opposite angles of a parallelogram. Okay, PARM. Well done. I also got a correct answer from someone online. Well done. And then let's go to someone else. What size will B be? What size? Yeah, there we go. There's a hand there. Yep. Opposite sides of a parallelogram. Okay. Sides of a parallelogram. How do I know it's a parallelogram? Because both pairs of opposite sides are parallel. All right, I'm looking for an answer for C and then for D. And guys, just give me a reason. Da, da, da.
C.
All right, I must have a reason, no? Okay, angle C. 51. Why?
I'm a base
Interior
angle.
angle of a triangle.
So what we actually say is we say angles that are opposite equal sides. Okay, there's the equal sides, and these angles are opposite equal sides. Remember what I told you about the semi rule? The biggest is opposite the biggest. The smallest is opposite the smallest. If two are equal, then the two angles have to be equal. All right, and you can tell me what size is angle D and why?
78.
Okay, someone online has told me, tell me, 78. Sorry, you can tell me why?
Angles on a straight line.
No, not angles on a straight line.
Angles on a triangle. Interior and
Because angles of a triangle.
Okay, angles of a triangle.
180
Okay, well done.
degrees.
All right. Who can tell me about E and F?
E is equal to 124.
Okay, I'm just muting that for now. Okay, you are right. I'm looking for an answer here in the room.
E equals
24.
Okay, guys, you can't say just corresponding angles equal, unfortunately. All right, why? Yeah, guys, the parallel lines are so important. I don't know if you remember when I was holding them up, I said the lines have to be parallel. So you're right, corresponding angles, parallel lines. You must say parallel lines, but you deserve a sweet, definitely. And then F. What size, if E is 124, what size is F? 50? 56 degrees. Why?
Oh, F.
Angles on a straight
And
line.
all the straight line add up to 180.
Okay. Right. Now, guys, this shape here. I want someone to tell me, Yini there, what is this shape? It's not a kite.
It's a rhombus.
It's a rhombus, guys. A rhombus has got all four sides equal.
Yes.
Look at this. A rhombus is like a square that's been hit by a bus. Okay.
Yes.
Just remember that a rhombus is like a square that's been knocked over. A parallelogram is like a rectangle that's been bumped. Okay. Right. This is a rhombus. Now, you need to learn the properties of the rhombus. Who can tell me what is G? And what is H? And I want to reason. Just give me a reason.
G is half.
What do we know about the diagonals of a rhombus? You might want to go and look at the picture here.
Diagonals bisect each other.
Okay, there's two things about the diagonals of a rhombus. They bisect at 90 degrees, but also they bisect the angles. Okay, so what will G be? G will be 90 degrees. And we can just say diagonals of rhombus. What will H be? H will be 63 degrees. And again, we can just say diags of rhombus.
Rhombus.
Okay, because the diagonals of a rhombus bisect the angles. Now, the next shape I didn't tell you about, but guys, I want you to try and finish the rest of these questions. Okay, I'm going to be back shortly. I want you to try and do the rest of them. You're welcome to discuss them, and then we'll carry on. So just take a couple of minutes on the rest of those.
At the end of the lesson, please start by me and some paintings from your from social minutes.
Right, guys, it's going on. What shape? Thanks, guys. What shape is this one? It's a kite. So what size is K? Right, guys, the diagonals of a kite are at 90 degrees to one another. Diags of kite. What size is M? M must be 9,2. All right. And guys, the reason for that is that the long diagonal bisects the short diagonal. Okay, guys, just tool a bit. Okay, because it's hard for people to concentrate. And then what size must J be? J must be 29 degrees. Okay. And it's 29 degrees also because the diagonals of a kite, they bisect, those angles are bisected and so are those angles. Okay, who can give me an equation for this one? Who can make an equation? And remember, an equation has an equal sign. Yes, there's a hand there. There we go. 6x plus x plus 20 equals 8x. Just give me a reason. Yeah, well done. Exterior angle of triangle. Well done. Can you solve that equation for me while you've got the microphone? Sorry. On which side? Well done. On both sides. Well done. Hala. Okay. Uyingobile. Okay. Right. Okay. This one over here. Okay, this one over here is a little bit tricky. What we're going to do, I'm going to draw in another parallel line here. Okay, I'm going to try and do that. I'm going to try that again. I'm going to see if I can do it a bit better. Okay, so I'm going to draw in. Yeah, still not very good. And I'm going to call this P1 and P2. Okay, who can tell me what is P1 going to be and why? Turn the diagram around. Sometimes it helps to turn the diagram around. Over here, we've got an answer for P1. Okay, what will P1 be? Guys, this is parallel. What will
P1.
49.
Also nicht Englisch. Sangamuzwa manje umlungu, guys.
Usesifake ku-mute.
Hayi-ke.
Hayi ke, ubesana wayenza-ke.
Hayibo guys, kwenzakalani manje?
Ayiveli futhi nale message le ejele kuvele ethi unmute. Somtshela kanjani-ke? And usifake ku-mute. Shame. Uyokuthisha.
Lapho uyaqhubeka uyenza.
Yibo guys yo. Sazi ukuthi kuzobe kwenzakalani ngibeka. And akanakile yazi.
Hayibo.
Ayike. Somcela abuyele emuva sesho ukuthi besimutile. Ngizomcela mina ingeke guys yo. Esibhaleni senze njani?
Kuza kuqeda bhala. Kambe qeda sikhathini ungaqaseni. Lungasifuzwa.
Bhalani guys izochaza ukuthi sebona ukuthi usifake ku-mute. Hayi uyashosholoza-ke manje. Hayi ngeke.
Hayibo.
Vele
Hayi.
u-screenshot.
Washiya manje.
Ngiyakutshela uyambona ugijimani.
Lapho ngisaka ama-cointeria.
Lapha kwi-palm. Kule shape le athi iyi-palm. Yini?
Liyaqeda kuyibhala nje uthi izikhothi 10.
Oh le. Sechaza yiphi-ke manje? Nje bese deba ama-triangle awu-2.
Uchaza le
Le yokugcina.
anothi number guys.
Uyashosholoza-ke manje.
Safana njalo ukula ngisashaya.
Yebo. Simsendeleni ilo i-message guys. Ngempela.
Yeah, I'm muted. Okay. Sorry, I've just unmuted myself. I see someone's trying to phone me. I'm hoping it's about that. I'm not going to take the call. Yeah. All right. Okay, so you can hear me again now. I'm sorry, I don't know how long that was a problem for. All right, but I think you can hear me. Right. So, guys, what we know here is that DE.
Sorry.
Yes.
We were left. You were explaining while you were muting us.
I know.
We didn't hear you in the other questions that you were explaining.
Well, yeah, but I don't know. I don't know how many. Like, yeah. I'm hoping you could at least see what was happening. So this one, the one that we did most recently was these two angles, because the lines are parallel, these two angles must add up to 180 degrees because they are co-interior angles, and then we solved that equation. This one, DE, must be parallel to AB, okay? And the reason it must be parallel is this is the converse of the midpoint theorem. Okay, now if these lines are parallel, and they are parallel, I've given a reason, then who can tell me about these two angles? They must be equal. So 4u plus 20 must be 2u plus 40. And I need a reason again, and the reason is corresponding angles, but absolutely in parallel. I must say parallel lines. Now I want to solve this little equation. I'm going to subtract 2u from both sides. Now I'm going to subtract 20 from both sides. And lastly, I'm going to divide both sides by 2. Okay. All right, guys, we're gonna move on now to some true-false questions. Okay, and there are lots of them, and they're all around. And I want you to try and picture the shapes. So the diagonals of a parallelogram are equal in length. We're going to do these together. True or false? It's not true, guys. Look here. And unfortunately the learners online probably can't see, but when I've got, look at an extreme case. So if I've got a parallelogram that's like the, okay, if I've got, guys, it's definitely false.
False.
All parallelograms are rectangles. True or false? This is a rectangle. This isn't a rectangle. Okay. This is false. All rhombuses are parallelograms. True. True, because the opposite sides are parallel. True. The diagonals of a rhombus bisect one another. True or false? It's true because this is also a parallelogram. It's true. The diagonals of a parallelogram bisect the angles.
True.
True.
Guys, I don't know if we're guessing or what, but which shape do the diagonals bisect the angles? A rhombus and the perfect quadrilateral, which is a square, because I remember a square is a special rhombus. All rhombuses are squares. A corner. Guys, is this a square? This is not a square. Okay. All right. All squares are rhombuses. Not all rhombuses are squares. Okay. So this is false. Right. Now, guys, I want you to think about, maybe many of you do life sciences. Okay. I don't know if you do. All right. I want you to think about like a picture like this. Do you agree that cows are mammals? Yes. Can you see that all cows are mammals? All cows are mammals? Yes. Are all mammals cows? No, because maybe here you've got like a dog or something else. Okay. All right. So it's the same idea. If the diagonals of a quadrilateral bisect one another, it must be a rhombus. True or false? False. Guys, it must be a parallelogram. If the diagonals bisect, it will be a parallelogram. A square has all the properties of a rhombus. True. Guys? All rectangles are parallelograms. Guys, all rectangles are parallelograms. True. A kite has two pairs of adjacent sides. Adjacent means next to each other. Equal. True. True. If a quadrilateral has one pair of sides equal and parallel, it must be a parallelogram. Guys, look at this. So that's equal and parallel. It must be a parallelogram. True. Right? The opposite angles, picture the parallelogram. The opposite angles of a parallelogram are equal. True or false? They are equal. True. The diagonals of a rhombus bisect the angles. True or false? Guys, you need to learn these things. It's true. A rectangle has all the properties of a square. False.
False.
Okay. A square has all the properties of a rectangle, not the other way around. Okay. If we have a quadrilateral with opposite sides equal, then it is a parallelogram. True. If the diagonals of a quadrilateral bisect one another at 90 degrees, it must be a rhombus. True. All right. A shape with all four sides equal must be a square.
True.
False. It could be it might, guys. This has got all four sides equal. Is it a square? No. It could be a rhombus. Thanks, guys.
Okay.
A quadrilateral with opposite angles equal as a rhombus is false. It could be a parallelogram without being a rhombus. Both diagonals of a kite bisect one another. Both. False, guys. This one does, this one does not. Okay. All squares are rhombuses. True.
True.
Right. Okay. Right, guys, I want you to just listen here. Okay. I'm going to draw another little picture for you here. And you might want to get this down at the bottom of page 17. Of our quadrilaterals, inside here we've got parallelograms. Okay, and inside the parallelograms, there are two types. There's rhombuses and there's rectangles. Okay, and then inside here is the square. So just listen carefully. Is a square a parallelogram? Yes. Is a square a rhombus? Yes. Is a rhombus a rectangle? No. Okay. Are all parallelograms rectangles? No. Are all rectangles parallelograms? Yes. Okay. All right. I hope that little diagram might help. You might want to just quickly take it down. Okay, right. Now, guys, we're going to do some examples now, and the next 3 examples are the last things that we're doing here. They all involve proving congruency. All right, so prove that this is a parallelogram. All we are told is that the opposite sides, this pair of sides is parallel, and this side is equal to this side. prove that it's a parallelogram. Now, watch what we're going to do. Guys, just okay. I'm going to join this. All right? And I'm going to try and prove that these two triangles are congruent. Okay? And I'm going to show you why I'm going to do that. Because if I do that, then I can prove that some angles are equal. And if I do that, I can prove that I've got some parallel lines. Okay, so in triangle ADC and triangle ABC, what do we know so far? Can anyone tell me anything that we know that's equal in those two triangles? We know that AD is equal to BC. And the reason for that is it's given. Okay. Thanks, guys. We also know that AC is common. So far I've got a side and another side. Now, let's just quickly remind ourselves, you did tell me earlier, right angle hypotenuse side, 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 angle side, and angle side. Okay, cool. I want to try and prove these triangles congruent. I don't know about DC and AB, so that's not going to work. Compared to a 90 degree, that's not going to work. Okay, I don't have any angles yet. Who can tell me an angle that must be equal in these two triangles? There's one angle in each triangle that is equal, and why? Just give me a reason. Okay, who can tell me which angle is equal to DAC? DAC must equal another angle in this diagram. DAC. ACB. Why are these two angles equal, guys? I need a reason. Well done. They are alternate angles. Cordwa, I must say that the lines are parallel. AD is parallel to BC. And what have I got there? I've got an angle. Now, have I got one of these? Yes, I have. I've got side, angle, side. So, what do I know? I can write down that the triangles are congruent. Triangle, I'm going to go with ABC. Triangle ABC is congruent. Guys, watch where I'm starting. I've gone ABC. Which one do you think it's congruent to? CDB. No. DBC. No. ABC. CDA. CDA. All right. What's my reason? Side, angle, side. Side, angle, side. Okay. Now, guys, because it's congruent, if I've listed it correctly, then I can pull out another angle that will be equal. I'm going to look at angle BAC. Angle BAC. Now I want you to watch where I'm going here. I'm going BAC. What must that be equal to? Look here, middle, first, last. Middle, first, last. DCA. And now the reason for this is because these triangles are congruent. Cordwa, the very last thing. If these angles are equal, because I've now proved those angles are equal, what do I know about these lines AB and CD? They must be parallel. AB is parallel to CD. Why are they parallel? Because the alternate angles are equal. And now, is it a parallelogram, guys? Yes, it must be a parallelogram Therefore, it's a parallelogram, and we can just write PARM for parallelogram, because the opposite sides are parallel, because I've now proved that AB is parallel to CD. Opposite sides parallel. Okay, I want to just talk to you about what we've done here. The first thing we did is we drew in the diagonal. That gave us some triangles. Then we proved the triangles congruent. Then, because the triangles were congruent, we worked out that these two angles here were equal. Because these two angles are equal, these lines are parallel. Because we've got two pairs of parallel lines, it is a parallelogram. Okay. All right, we're going to do another one. It also involves congruency. Okay. And we're going to try and prove that this side here is equal to that side, and that that is equal to that. That's what we're trying to do. But we're going to try and use congruency. All right. Guys, I want you to see if you can prove for me that this yellow triangle, I'm going to give you a minute or two. I want you to see if you can prove that the yellow triangle is congruent, identical to this green triangle. The yellow one and the green one. Let's see if we can prove them identical. What sort of shape is this? The big shape. The big shape is a parallelogram. Okay. What do we know about the opposite sides of a parallelogram? They're equal. So this here is equal to this here. Now I want you to see if you can use what I've told you to prove the green one and the yellow one congruent. I'm going to put some little numbers on here just to make our lives easier. And I'm going to put a label over here. I'm going to call this E in the middle here. Right, guys, these ones that we're doing now are listed as required for your exam. I've seen the document from the department. It says you need to know these proofs. Who can tell me anything we know? So far we know that AB equals CD. Opposite sides of a parallelogram. Yeah, maybe just put your hand up so that we can get the microphone. So guys, I've got a sign. If you can tell me anything else about the yellow triangle and the green triangle, just put your hand up. There we go. Ayanda will bring you a microphone and a sweet, maybe. Thanks, guys. Just listen carefully. Listen carefully. Sorry, what equals to? E1 equals E2. Thank you. Why? Okay, so E1 equals E2. So we're saying that there is equal to that there. Vertically opposite angles. Vert-op angles. Just keep the microphone if you don't mind. Okay, well done. That's an angle. Now, guys, remember, I can't start saying that AE equals EC because that's what I'm trying to prove. I need some other piece of information that's going to make these triangles congruent. Can you tell me about another angle in these two triangles? Can you tell me what A1 equals? What does A1 equal? Y. Well done. A1 is equal to C2 because they are alternate angles, but don't forget to say which lines are parallel. Okay, AB is parallel to CD. And that is a side. That's not a side, that's an angle. Have we got enough for congruency? Angle, side, yes. So while you've got the microphone, if I write down triangle ABE, triangle ABE, congruent, what order must I write this next one down in? Well done. C, not CED, no. No. So have a look, you went from A, which has got the red on, so you must start at C. Well done. C, D, E. C, D, E. And the reason we've got to end with E is because the two E's are equal. What's my reason here for the congruency? And remember, there's only 4 possibilities. Well done. Okay. Now, the last thing, because these are congruent, if I take AE out of here, what must it equal out of the other one? Guys, look at this. AE, the first and the last, must equal CE. Okay? So I've now proved that this diagonal is cut in half. What if I take BE, look at here, the middle and the last, what must I take from the other one? Correct. BE equals DE. Why am I allowed to take these things out? Because I've got congruent triangles. Okay, and so I've now done it. Therefore, the diagonals bisect. Because I've shown that AE is equal to CE and BE equals DE. All right. Okay, guys, I'm not going to do the last question just because I want us to get onto analytical geometry. But look here. If I draw in the diagonal, how many triangles have I got now? 2. Do you think I could prove them? Congruent? And now, guys, we're trying to prove that the opposite sides and angles are equal. So you can't tell me B is equal to D. Who can tell me, and we're not going to write it down neatly, but who can tell me one fact between these two triangles? AC is common. Okay. Anyone else tell me another fact? So far I've got a side.
BC is equal to AD.
Why? I can't say BC is equal to AD because that's what I'm trying to prove. Okay, so I can't, guys, listen carefully to this. I cannot use opposite sides equal because I'm trying to prove that. I can't use opposite angles equal. All I've got are these parallel lines. Can anyone tell me if this is 1 and 2 and this is 1 and 2? Can anyone tell me about C2? What is C2 going to be equal to?
A2.
C2 will equal A2. Why?
A2.
Alternate angles. So far, I've got the common side and I've got an angle. Who can tell me something about C1? And you might want to turn your diagram around. Okay?
C1 is equal to A1.
C1 is actually equal to A1. All right? Because they are also alternate angles. Angle, side. So I can prove them congruent. I'm not going to write it down now, guys. I'm going to move on to our last topic. All right? We've just got like 45 minutes left. And our last topic is around analytical geometry. Now, I'm not going to look at any of this stuff. I'm going to leave you to look at this stuff. But I'm going to quickly show you some sketches here. All right. Okay. So this topic is all around points and lines. I've got a green point and I've got a blue point. Okay. And I'm going to ask Ayanda to just quickly find someone. I want you to tell me the coordinates of both points. Okay, in other words, what are their names? The green point and the blue point. Yeah, here we go over here. There's a Jabula learner. There's another Jabula learner there. Tell me the blue point first. The blue point. Guys, just please keep quiet. Okay. I know you're tired. Hey. Guys. All right, we can't do these sessions if it's going to, I know it's a long time. I don't mind if you have to run out quickly and go to the toilet, just do it quietly, okay? But we can't now stop because we're tired. We need to carry on, and we need to try and get as much out of it as possible. Give me please the coordinates of the blue point.
1 is to 3.
Well done. There it is. 1 is to 3. And the green point? Well done. Okay. Are we all comfortable with finding the coordinates of points? Okay. Now, guys, there's a line that joins those 2 points. I want to show you the way that I like to teach gradient and things. So I'm going to start off with gradient. Gradient is rise over run. So when I go from the from the green point to the red point, I rise up 5. Do you see that? 1, 2, 3, 4, 5. I can also see that I'm going from -2 up to 3. It's 5. What's the run? How much have I run across? I've run across 3. So the gradient will be 5 over 3. Positive gradients go uphill as we look at it left to right. Okay, now, so I'm going to turn these off and I'm going to put these points somewhere else. Okay, I'm going to put this point over here and I'm going to put this point over here. Now, my rise is actually a negative. How much have I dropped from the green point to the blue point? How much have I dropped? Okay, guys, I'm actually going to move this point. I'm going to put it there. How much have I dropped? No, how much have I dropped? From the blue, sorry, from the green to the blue, I've dropped 6. Okay, it's actually 6. How much have I run across from the green to the blue? 8. So the gradient is negative 6 over 8. Look at the gradient. Negative 6 over 8. Guys, negative 6 over 8 is the same as negative 3/4. That's the calculation. I don't actually do it using the calculation. Okay. All right, I'm going to do one more. How much have I risen when I move from the left to the right? How much have I risen? Only 1. How much have I run across? No, guys, I've risen 1. I've run 6. Run is left to right, and rise is up down. So what's the gradient? It's going to be 1 over 6. There's the gradient, 1 over 6. Okay, as a decimal. All right. Now, if I'm talking about the length of a line, okay, I'm just going to do exactly the same thing, but what would I do to find the length of this line? I would use Pythagoras. Okay, look at the length of the line. It's just going to be 6 squared plus 1 squared, 36 plus 1, 37, and then we square it. The distance formula is just Pythagoras. Okay, and then the last one that I want us to look at is this one over here. If I ask you to find the midpoint of this line, now listen carefully to how I do this. I know you guys get a formula, and what you do is you say, well, let's just add the x's and divide by 2. I want to ask you, how far have I run from the green to the blue? It's 10. It's from -6 to 4. What is half of 10? 5. If you go -6 and you add 5, you get to -1. That will be the x coordinate of the midpoint. How much have I risen from the green point to the blue point? 4. What's half of 4? 2. If you add 2 to -2, you get to there. Norma, if you subtract 2 from the blue point, you get to there. The midpoint is actually -1, 0. Now, the reason that my method is better than the formula is because I can work out any ratio along a line. Okay, so we're gonna look at some examples now. Okay, let's look at this. I want us just to quickly do question 1 on this page. Just the whole of question. Sorry, let's just do 1A to D to start off with. 1A, B, C, D. You can talk to each other about it. The first question we are asking is, what's the gradient of AB, of this line? Guys, is it a positive or a negative gradient? Negative, definitely. It's going downhill. All right, I'm going to answer some of these questions sort of all up here. You can obviously answer them in the right place in your book. Oh, sorry. Yes. All right, guys, so first up, who can tell me what is the gradient of AB? The gradient of AB, I'm going to write MAB. Right, guys, it's dropping down. Well done, it's -8. It's dropping down -16, okay? And it's running across 2. -16 over 2, -8. I know that many of you would have done that using the formula. I don't use the formula. If you want to use the formula, 10 minus -6, y value minus y value, over x value minus x value. So 4 minus 6. So we get 16 over -2, we get -8. All right. The next question asks us to find the perimeter of this triangle ABC. The perimeter means all the way around the outside. So what formula am I going to need to use? My distance formula. Huh? Okay, so the distance formula for AB, the perimeter is going to be AB plus BC plus AC or CA. Okay, this one is going to be, and it's easy because I've just worked out the gradient. The distance that the sort of just the x change is 2, so it's going to be 2 squared, and the y change is 16. It's going to be 16 squared. Okay, I'm going to do BC slightly more slowly. I'm going to go -8 minus 6, -8 minus 6 squared, okay, and -2 minus -6 squared. Okay, and the last one, CA. I'm going to do CA a bit more quickly. How much does it run across from -8 to 4? -8 to 4 is 12. And from -2 to 10, 12. Right. This is 256. This is 4. This one is the square root of 260. This is 196, 14 squared, 196. And this one is, sorry, this should be a plus here. This is 36 plus, no, sorry, this is, what? No. So it's not a plus. It's a minus. Minus 2. Yeah, there's a bracket missing. That's what's confusing me. Minus 2 plus 6. This is 4 squared, and this one is 14 squared. So it's 16 and 196 is 212. This one is the square root of 288. Okay, 144 plus 144. Okay, I'll just quickly work it out for us. Going to be the square root of 260 plus the square root of 212 plus the square root of 288. Okay, we get about 47,7. Okay, I hope I haven't made any silly errors there, but all right. Then question C says find the midpoint. Guys, the midpoint of this line. All right. So I'm going to show you two ways of doing it. One is to use the formula. If we use the formula, we add the x values and divide by 2. So we get 4 plus 6 is 10, divided by 2 is 5. I don't do it like that. I say, how much have I run across? I run across 2. What's half of 2? It's 1. I can either add 1 to 4 to get 5, or I can subtract 1 from 6 to get 5. Okay. This is going to be 10 and minus 6. If you add those together, you get 4, and you divide by 2, you get 2. Okay, so there's the midpoint. I've got the wrong line. Okay, all right. You can tell him much. Okay, all right. Sorry, guys. If I move from minus 8 to 4, that's a total distance of 12. Half of 12 is 6. If I add 6 to minus 8, I get negative 2. If I subtract 6 from 4, I get negative 2. From negative 2 to 10 is a climb of 12. Half of 12 is 6. Add 6 to minus 2 and I get to 4. Normally subtract 6 from 10 and I get to 4. You can either do it like that, or you can just add the x's and divide by 2. 4 and minus 8 is minus 4, divided by 2 is minus 2. Right? And negative 2 and 10 is 8, divided by 2 is 4. Okay. All right. Then it says, what about the equation of this line AC? All right. So this is the answer to C. All right. The equation of AC. I know I'm doing this all over the place, but I'm just trying to keep the diagram here. What's the equation of this line? What do I need to know first? I need to know its gradient. What is the gradient of AC? Okay. Guys, it's risen 12. And it's run across 12. The gradient is 1. Okay. What's the standard form for a straight line? Y equals mx plus c. So now what I'm going to do, I'm going to put in the gradient and I'm going to put in a point. The easier point, I think, is going to be this one because it's positive. So 10 is the y value. The gradient is 1. The x value is 4 plus c. How many variables are left in here? Any longer, just 1. Okay, so now I can subtract 4 from both sides. And I get c equals 6. So my final answer is y equals 1x plus 6. And if I go and look here, guys, this point over here is the y-intercept at 6. It looks about right. That was at 4, it's a bit higher up at 6. Okay, question E. Determine the gradient of AB. What? Okay, guys, question E we've already done. Question E is the same as question question A. Now, have a look at this. It asks us, what's the coordinates of point D if A, B, C, D is a parallelogram? So I want us to look. D is going to be over here somewhere. Okay, and I'm going to end up with a parallelogram. Now I'm going to show you a clever way of doing this. Guys, what do we know about the opposite sides of a parallelogram? They are equal and they are parallel. So if I do that, that must be parallel and equal with this, so these two blue lines must be the same. Now, because they're the same, they've got the same gradient and the same length. Just listen carefully, guys, here. What happens to my x when I go from B to A? What happens to x? It gets smaller by 2. So exactly the same must happen here. It must get smaller by 2. What happens to my y when I go from this point to this point? It gets bigger by how much? No, guys, from -6 up to 10 is not 4. So much bigger than 4. 16. It's growing by 16. So this one must grow by 16 from -2 up to 14. Okay, I want to show you another way that we can check our answer. Look at this side here and look at this side here. Now, when I go from B to C, what happens to my x? How much does it reduce by? It goes from 6 to -8. What's 6 to -8? How much is it getting smaller? It's getting smaller by 14. If 4 gets smaller by 14, what do I get? -10. What happens to my y when I go from this point to this point? It gets bigger by how much? From -6 to -2. Bigger by 4. So this y value must get bigger by 4. All right. And so there's the answer. It's -10, 14. But all I'm doing is I'm just using, those of you that do science, I'm using almost like what we call a vector. It's the same size, and it's also the same gradient. All right. Then question G. It says, find point E if A is the midpoint of CD. Find point E if A is the midpoint of CD. So now guys, look at this, and I know it's getting a bit messy here, but A is the midpoint, guys, this question is faulty, sorry. So let's leave question G. It's actually, question G has actually got a problem in it. I think it's meant to be, just change this question to the midpoint of CE. CE. Right. So find E if A is the midpoint of CE. Now I'm just going to draw it here. Here's C. C is -8, -2. A is 4, 10. And E is up here somewhere. And I don't know that. Okay. But what it's saying is that A is the midpoint of CE. Now, I'm going to show you 2 ways of doing this. I'm going to do this question once with a green pen and once with a blue pen. The way I would do it, guys, if this is the middle, how far have I moved from here to here? How far has my x moved? How far has my x moved? From -8 to 4. It's moved by 12. It's moved by 12 and I'm only halfway, so it must move by another 12. Okay, it's moved by 12, it must move by another 12. How far has my y moved? It's moved by 8, it must move by another 8. And there's my answer. Okay, that's how I would do this question. I suspect many of you wouldn't do it like that. You would use a formula. You would say, let this be x and let this be y. Okay? Now, how do you find the midpoint of a line? You add the x's of the endpoints, x plus -8, and you divide by 2, and that gives you 4. And you do the same with the y values. Y plus 2 over 2 must equal 10. Okay, so if you choose to, you can do it like this. Now guys, I'm going to multiply by 2 on both sides here. So I get x minus 8 equals 8. I'm going to multiply by 2 on both sides here. I get y plus 2 equals 20. I'm going to subtract, so I'm going to add 8 to both sides here. And I get x is 16. And I'm going to subtract 2 from both sides here, and I get y is 18. So there I get exactly the same answer, but I think you can see the green was much less working. It was actually much less. It was just thinking, I've gone so far, I must go the same amount again. Okay, does it make sense? It always makes sense. Only a few of you said it makes sense, but it always makes sense. All right, we're not going to have time to do all these questions. I want to do question H, all right? Because 1/4 of the way between C and A. Here's C. -8, 2. And here's A. 4, 10. And I want to go 1/4 of the way. All right, in other words, that's about half. So I want to find this point over here. It's 1/4 of the way. Now listen carefully to this, because one thing you could do, all right, you could find the midpoint, and then you could find the midpoint again, because that would give you 1/4. But I want to show you the way I would do it. Guys, listen carefully to this. How far has my x changed? How far have I run across? From -8 to 4, how far have I run across? 12, okay? And how far have I risen up? I've risen up 8. Now, what is 1/4 of 12? 1/4 of 12 is 3. So this point is going to be -8 plus 1/4 of 12. That's going to be the x value. The y value is going to be 2 plus 1/4 of the y change. And we can see, what's 1/4 of 12? We said it's 3, -8 plus 3, -5. 1/4 of 8 is 2, 2 plus 2, 4. -5, 4 is a point that is 1/4 of the way between point C and point A. All right. This question is talking about our distance formula. So we want the distance from B to E to equal 5. Okay? B is 6, -6. And E is 10K. And I want the distance between B and E to be 5. What's my distance formula? Who can tell me? D equals
Say
x1 minus x2 squared plus y1 minus y2 squared. Okay, so
sorry.
yes.
Where did you find the coordinates of B?
The coordinates of B it's in the question, so it's because we still talking about the same question. Okay.
Oh, okay.
So it's that point there. Okay. Because this is question 1. This is A, B, C, D, E, F, G. We're on the very last part of this question. Thank you
So
for asking.
into all of this question, we're looking at the diagram. The same diagram.
Correct. And that's
Okay,
why
thank you.
in your workbook, you should be able to see it all at once, guys. So page 22 and page 23, they're what we call facing pages. So you don't have to pendula ikasi. You can look at the whole thing. Okay. For me, it's difficult here because I haven't got the sketch anymore in front of me because the sketch is gone off up here. Okay. But now, guys, let's use this formula to find this. So the distance, we know that the distance must be 5. Okay? B is 6 minus 6 and E is 10k. So using my distance formula, I'm going to get 6 minus 10 and I'm going to get minus 6 minus k. Okay. How many variables are in this equation? Just one, just k. Right, now, who can tell me what could I do to both sides to get rid of this? I could square both sides. If I square both sides, this becomes 25. And this square root sign goes away. So what I've got now, I've got 6 minus 10, minus 4 squared. And here I've got minus 6 minus k squared. Okay. It's looking better because the square root sign's gone. This is just 16. You can suggest, what could I do next to both sides? I could subtract the 16 from both sides and I get 9. Now, we can choose. One thing we could do is we could square out this bracket on the right-hand side, collect all our terms, get 0 on the one side, and then factorize it. That's not the cleverest way of doing it. If I just square root both sides now, guys, square root both sides, this square will go away. And I'll get minus 6 minus k. What's the square root of 9? 3. Cordwa, don't forget, when you square root 9, you can also get minus 3. And now, it's easy to solve for k, all right? I'm going to add 6 to both sides. So I'm going to get 6 plus or minus 3 is minus k. Now, if I add 6 to 3, if I go 6 plus 3, I'm going to get 9. If I go 6 minus 3, I'm going to get 3. Okay? And this is a much quicker way of doing it. You'd get the same answers if you multiplied it out, right? Okay, so what should I do to both sides now to get k? I'm just going to divide by minus 1. And there's my 2 answers. All right, I want us to look at question 3. Okay, because it's maybe a little bit tricky, all right? All right, guys, what do we know What do we know about perpendicular lines? Who can tell me about perpendicular lines? What do we know about their gradients?
They're equal to 180 degrees.
The same gradient.
Just say it a bit louder. The product of the gradients is -1. So, for example, 2/7 would be perpendicular to -7/2. So, to find a perpendicular gradient, you're going to turn it over and you're going to change the sign. Now, is this line in standard form? Is it in standard y equals mx plus c form? No, it's not. So the first thing we're going to do here, we're going to try and get the y on its own. So look at this, guys. 2x plus 4y equals 12. Let's subtract 2x from both sides. What should I do to both sides now to get y? Divide by 4. I'm going to get -2/4x plus 12 divided by 4 is 3. Who can tell me what's the gradient of this line? The gradient of this line, or this line, or this line. Guys, where do we get the gradient from? The gradient is the number, the coefficient of x. So this line has got a gradient of -0.5. Who can tell me what will be what's perpendicular to -0.5? What gradient?
It's 2/1.
Well done, it'll be 2/1. All right, so we want a line that's perpendicular gradient is 2. Is everyone okay with that? What I've done is I've just turned that gradient upside down and I've changed the sign. Now, we want a line that's got that gradient, because that will make it perpendicular to this line, but it must have the same y-intercept as this line. Is this line in standard form? No. Guys, this line's got 2y equals. What's standard form? Standard form is y equals mx plus c. What must I do to both sides to get y? Divide by 2. So I'm going to get y is 1/2 x plus 3. What's this graph's y-intercept?
It's 12.
This graph here, its y-intercept is 3, guys. The y-intercept is found by letting x be 0.
Equal to 0.
Yeah, if you let x be 0, then the y-intercept is 3. Okay, and now I'm ready to write down my final answer. Because I want a line that's got a gradient of 2 and a y-intercept of 3. A gradient of 2, remember y equals your gradient times x plus your y-intercept. It's a good question because it tests quite thoroughly that you understand all the stuff that's going on here. This is a straight line. It's not in standard form. The first thing we do is we put it into standard form, and that tells us what this line's gradient is. Now we want a line that is perpendicular, so I need to turn it over and change the sign. Okay? And then we want the y-intercept to be the same as this line. This line wasn't in standard form, so I put it into standard form, right? And that gives me the y-intercept. And now I know the gradient is 2 and the y-intercept is 3. And there's my final answer. It's not an easy question. Now, the last question we're going to look at today, all right, is number 4. And it talks about collinear. Now, what I want to show you, and I want to encourage you to go and read it tonight and tomorrow, is it does explain here around things like collinear. Points which are collinear, guys, maybe just go to this page, it's page 19. Points which are collinear lie on a straight line. That means that the gradient from A to B must be the same as the gradient from B to see. Look at my, guys, just look at my arms here. If this line and this line have different gradients, then the points will not be on a straight line. The gradients need to be the same. Okay, so we're going to try and show, as our last question, we're going to try and show that these points are all on the same straight line. We're going to work out the gradient of AB, and we're going to work out the gradient of BC. Now, remember our gradient formula? We go y value minus y value, so y1 minus y2 over x1 minus x2. And the same here, y1 minus y2, x1 minus x2. All right, so for AB, let's go p squared minus 1 over p minus 1. And I'm going to do BC at the same time here. P squared minus 2p minus 1 and p minus 1. Okay. This one's p squared minus 1 over p plus 1. This one is p squared minus 2p plus 1 over p minus 1. Now, guys, I want to show that these two things are the same. All right. And this comes now to some normal algebra, because I want us to try and factorize and simplify. Who can tell me how does p squared minus 1 factorize? It's an easy one. It's what we call a difference of two squares. Guys, how does p squared minus 1 factorize? P minus 1? Yeah, p minus 1, p plus 1, or p plus 1, p minus 1. So what can I do here to simplify? I can divide and divide. So the gradient from A to B is p minus 1. Now, I want to show that this is also p minus 1. Who can tell me why this is also p minus 1? Who can factorize the top here? It's going to be a p and a p, and then the signs must both be the same, and they must both be negative, and a 1 and a 1. Okay?
Factors of 2, factors of 1, that's when we add, give us 2, and this is 1 and 1.
Correct. Okay, I'm talking to someone online here as well, but I'm going to get a minus 1p and a minus 1p. This is correct. Now, guys, this can divide, and these are the same. And if they're the same, what that means, guys, I've got a gradient here, and then my next line is at exactly it doesn't change. It doesn't do that. It doesn't do that. Okay, it does that. Okay, not very well done. It does that. Okay, it's the same gradient. Okay, so since they're the same, the points, this point, and this point are collinear. Collinear means that they lie on the same line. Okay, right. Okay, guys, we're gonna stop there.